It is my pleasure to welcome a true giant of software development. Please welcome Warren Vernon.
Thank you. All right, stochastic architecture. I thought a very appropriate, practical way of approaching this topic is to understand what we can trust and what we can do with LLMs, with architecture, and using Gen AI. So how many of you here are actually using Gen AI on a regular basis? Wow, okay. But that's still maybe a little more than half, as far as I could see. So some of this might be, seem like old hat to you or familiar, maybe even boring by this point. I was in a little interview earlier, and I was asked some questions about the practicality of AI versus the hype that we've all experienced. I don't know about you, but to me, the hype, the messages that have been hyped have been pretty clearly hyped. I don't know how you view it. Do you buy into this, we're this close to super intelligence, and I don't know how many here think that we are actually this close to super intelligence, that models reason, that we actually experience an interaction with an intelligent creature being a creation, right? Software. Oh, okay. Well, so it's a lot different than CEOs then, I guess, right? So, that's true, though, evidently. Okay, so stochastic architecture. What is stochastic? This term came up, I think Emily Bender and some others at University of Washington came up with this description, stochastic parrot. And the reason for that is stochastic describes how LLMs work. Basically, there's a random probability distribution or pattern that is used with LLMs, and these may be analyzed statistically, and they are essentially not predictable from a precise standpoint. So the parrot part of this comes from the idea that you have something that repeats what it hears, right? Parrots hear something and they can repeat it, but they don't actually understand what they're saying. I mean, they might get some idea of it if Polly wants a cracker comes up enough and you hand Polly a cracker and Polly eats the cracker. Probably Polly, has some idea, conditioned reaction, like Pavlov's dogs, right? That there is something of interest there. They benefit from saying Polly wants a cracker. But do they actually know who Polly is? Do they actually know, precisely what a cracker is? If you explained how a cracker is made, its recipe, and how it's baked, would the parrot understand that? If you took some time to teach the parrot about the recipe, about the baking process, about how it's wrapped and put in a box and delivered to a store, and then you go to the store and purchase that and then bring it home and open it and give it to Polly, would Polly understand that? I don't think so. So a stochastic parrot is a fairly reasonable term to refer to an LLM. It's this metaphor for a large language model that is basically works on statistics and probability, predictive analysis, and it repeats what it knows. Okay, and by know, we're talking about data. So this is a look at a stochastic model, or the results of a stochastic model. So when you look at this graph here, what you're seeing is a range of information on a graph that has a wide distribution of hits on the model. And each of the different colors that you see here represents a different result in running the model. So if you ask the model about Polly wants a cracker, you're going to see these different lines on the graph, and which one of those lines represents what the fact is. Why does Polly want a cracker? What does Polly want a cracker mean? Whatever the prompt is that you give the LLM, it indicates here that there's a lot of randomness and uncertainty in what the model could understand and could give you as an answer. So this is what stochastic means. It's producing a very random set of information. So let's walk through this just a little bit. The first step here is we run the model many times. And as the model is run, we collect these randomly generated outputs into a collection of information. Okay, that's the first part of this. The second part is the results are analyzed together to form a comprehensive picture of what could happen. Okay, so what are the possibilities that could come up here as we go through the model and analyze it? The third part of this is the probability distribution. So we build this distribution from the results of the collection and the likelihoods of each of those possibilities. What could the outcome actually be if we were to choose a certain path? And then the fourth part of this is basically selecting a summary statistic. So how are we going to view this random distribution? Rather than just taking a final result, we have to take this whole collection of things and then basically say, okay, what is the summary that we're going to choose? And just as, like 3 different simple examples of the kind of summary we could choose is, we could say, give me the average or the mean of all of those things. Now, thinking back to that graph for a minute, that was just 5 or 6 different runs through the model. We're talking about, potentially thousands, tens of thousands, millions of runs. And so the distribution is much wider than you saw there in that example, which is just basically human readable, or we can comprehend what it means as a human. Another approach to this could be, well, let's take the median, which is the middle value. What's likely to be in the middle range of that, or we could take the extremes, the minimum and maximum of that. So those are just some very basic examples of how this could apply. Now, without actually, oversimplifying, does anybody recognize that? You haven't used Claude Code? Yeah, as you're working with Claude Code, it's outputting these little messages, and the asterisk is actually blinking. I haven't figured out how to make it blink here, but it's telling you I'm doing something. But I'm just saying here in imitation of, I'm parroting Claude sort of, and I'm saying without oversimplifying, LLMs are guessing. And that's just what they're doing. They're guessing at what the answer is. And, when it really comes down to it, it's kind of amazing that this stuff works at all, right? I mean, if you have used Claude Code, I've been using Claude Code a lot. I've used another LLM considerably. What I'll say is I've used another GenAI development tool, and I don't truly know what the model is behind it because the vendor doesn't disclose what model or models it's actually using. And I think that's because they want us to think that it's theirs, but it's not theirs. They're using someone else's model, and I don't know. I've been impressed by all of this, and I have also been deeply disturbed and disappointed by them. Have any of you found the same thing? I mean, in this one model that I was using, I don't actually want to say their name because I don't, want to kind of like, maybe your experience would be a little bit different, but, man, I started using this, and I remember like the second I worked 18 hours or something on this because my mind was just blown. Whoa, this is incredible. I cannot believe what I am seeing because, if we go back 3 years from this point, I was very disappointed, really, really disappointed in ChatGPT. I will name that one. And I could tell you that story a little bit later, but, now I'm seeing something far different, really amazing. And I just keep working. And after like 5 days, I'm starting to say, what's going on? It's not working as well as it was. And I don't know if it sensed the disappointment in me, because then it just deleted everything that I had. And I am talking about hundreds of source files. And this is not a joke. And that's sort of why I'm not going to even, well, maybe I should. No, I don't want to name this company because I think they're doing good things in general, but whew. And it took me days. I mean, I had backups of it, but at the time they didn't have this, generating to disk. It was all on the web. Maybe some of you are getting a hint as to what this product is, but it was only available on the web. And at the time you couldn't even write to GitHub or, push your commit and push your changes out to GitHub or anything. It was just all right there, self-contained on their platform. When something disappeared, even if you were downloading zip files of this, you couldn't actually build it on your local machine because whatever you downloaded was not the same thing that you were running online. So yeah, that's why I say the outcomes seem to defy the probabilities, because you think when, looking at any of this that it's impossible that it could actually work, and yet it does work. And it also doesn't work, right? And that's a really important point. It depends. That's what all this depends on. Now, I've worked on a couple of products here that I have open sourced. These are both the products of using Claude Code. Now, Claude Code was not at all on its own. This product, Domo Actors, is based on an open source reactive platform that I developed probably starting 8 years ago or more. Probably close, about 9 years ago or 10 years ago. I don't remember exactly. But this was it is a Java platform. It's called Xoom, Xoom. Germans have a really difficult time saying that, but it's like Zoom, like the communications platform. But that's how you say it. And it is an actor model. It's written in Java. It's meant to be used with Java. It's a set of libraries. So I have this actor model and the entire platform available. So I basically said to Claude, let's work through this. I'm basing Domo Actors, which is implemented for, it's TypeScript first. So it's based on, the runtime is JavaScript. And I've also produced, after the JavaScript or the TypeScript version, I also created one for Python. And you can find both of those out on my GitHub account. And then I also created Domo Tactical, which are the DDD tactical patterns. Not all of them, but the most useful ones that I created for TypeScript. And I have not duplicated those or created the Python edition for those yet. So you can look at those. So some of the things that I'll talk about here are based on this and some other things that I'm working on now. So what are the good and bad things? As in, what are LLMs good at doing and what are LLMs bad at doing? Being aware of these limitations is a good idea, because if you are practical, and I think, not a lot of people know this, but I'm married to a German. She and my son are both German U.S. dual citizenship, so I get the very pragmatic, very serious part of life. And I think you all are pretty pragmatic people, so you're going to want to know about this. Okay? So the reason is you want to use the things that LLMs are good at, and you want to avoid the things that LLMs are not good at or are bad at, because they're going to be traps for you. So the first thing is, AI is not a real brain. It just simply isn't. And I think I've established that point fairly well, but just in case nobody, or some here haven't clearly understood that, it's not that. So LLMs are not intelligent. Their understanding is simulated. The reasoning is simulated. The long-term context of an LLM, as in what's called the context window, or just the context, is limited. It's limited by the compute memory that's available, and simply the complexity of the larger the model, just trying to store the context, the tokens that are the result of some interaction with the model, is limited. And every now and then, the context window just needs to be cleaned up to free up room for more context in the future. And then you can either completely wipe out the context window, or you can wipe it out and summarize parts of it. Determinism. It's just not deterministic, right? The same input to an LLM will give you almost consistently a different answer every time. For people who say, well, let me save that prompt because that prompt worked really well, I want to run that again sometime, don't count on that prompt working for you the same way another time. Why? Well, you saw the probability distribution, and depending on where the model has been trained more recently, and even, sort of like dynamic gathering of information and learning from that, depending on the model and whether the team has actually been able to accomplish that, will change the results for you. Fact verifications. Ambiguity. Detecting playful or harmful speech, right? It's guessing. What do they mean by that? Oh, okay. Well, that must be good, right? No, it really cannot detect flavor in language, I guess is maybe a good way to put that. Dynamic learning. I think that there are some models that are achieving dynamic learning, like sort of like on-the-fly training based on user feedback. But most of the training, even the sort of disciplinary training that happens through the team. They are training the model in very specific ways. And I am not pretty much, as far as I can tell, able to perform much training on it myself, okay, on a given model. And biases are in the training data. So everything that the LLM has to train on comes from the internet, and apparently some places not on the internet too, which a lot of people aren't happy about, that they're able to, sort of reverse engineer or bring in information that is not on the open internet, or even that is, but is copyrighted, right? But the point is that the public information that it gets is the opinion and sometimes really strange opinions of people around the globe. Okay, what we would consider, not a real good social platform for it to learn from. LLMs are what they eat. And, if you've gone out to any kind of Git repository anywhere, and you've looked at sample information, and if you really pride yourself on being a good programmer, using good practices, good architecture, and you think you understand this really well, and you go out and you look at the wide sample of information, as in code, as data, right, that exists on the internet, you're probably really disappointed in some of the things that you find. And yet that is what the LLMs are training on. So like when I say, generate for me, Claude really wants to do things in a way that it knows most about. And a lot of what it knows most about are big ball of mud monoliths, poor naming, CRUD, bad coupling, code that has multiple confused responsibilities, right? This means like a class that's doing, instead of one thing really well, it's doing several things really confusingly, poorly, right? There are a lot of cyclic dependencies, large methods or functions out there. And Claude also has this, and all of them, I think, have this sort of propensity for not invented here, as in, ask it for, I want to use a UUID. And it says, oh, I'll generate a UUID generator for you, instead of just using the one that's associated with the language. And so you say, well, no, I would really rather have, a UUID that's well established and been used many millions of times or billions of times. And it says, well, no, this one's pretty good. You use it instead. And what I've actually found is that UUID is pretty common, even, even if there isn't one associated directly with the language, like there is with Java, for example, a UUID class. There are NPM packages, so Claude will normally say, oh, I'll go get this package. And if you say, well, are there dependencies on Node.js for that? Because I just want a vanilla V8 UUID. Oh, yeah, there are. Let me see. Oh, yeah, there's this other one over here that is, only needs V8 JavaScript engine. Okay, cool. I'll take that one, right? So it does know some of that, but if you ask it for a slightly less popular, such as a ULID, right? Or the case sortable, KSUID, case sortable random UI generator, it will generally say, oh, well, let me generate that for you. No, we can find one out there that's been used several million times, and let's go find that one. So sometimes you just have to go find those for it. But my point is, it really wants to generate code for you, even things that it really shouldn't bother doing. So they are what they eat. They just simply are. Now, why do you think that these LLMs would say, oh yeah, well, let me generate a KSUID generator for you? Is it because there just aren't that many KSUIDs out there, or is it mainly being trained on scientific papers or research information? I really don't know, but you would think that it would just say, oh yeah, well, there's one right here on npmjs.org, I think it is, or com. So, breaking news, LLMs are guessing. They really are. They're probabilistic. They're generating probabilistic architectures. They sometimes guess right. They many times guess wrong. And they're faster. Do you know this one from Superman? Like way back? Faster than a speeding bullet. You know, they can generate thousands of lines of code. Step away and grab a cup of coffee while you turn the LLM loose, and you come back, and there's way more there than you can possibly review even in hours. So you got to be very careful of that. You really need to tell the LLMs what patterns you want to use, how to use them, and then you have to be certain that they actually do. Now, I said I would refer to Domo Actors and Domo Tactical and some other things that I'm working on. And as I was working on Domo Tactical, the tactical patterns for DDD for TypeScript, I wanted everything, you know, all the main components in Tactical to be based on actors, because actors are the main concept, the main abstraction in Domo Actors, and that's what I was building on top of. And I would come back very often and find out that it was not using actors. It was using plain TypeScript classes. And it wasn't evident at first because it's doing a large part of the code generation in the way that I expected it to go. And you just sort of like get this level of trust because you've seen it work so many times before. And then all of a sudden, when you're not really expecting it to do what you didn't want it to do, it does what you didn't want it to do. And so, you know, you have to have this, don't let Claude, or, you know, I hate to just keep saying Claude because I really do really appreciate Claude and Claude Code, okay? So don't get the idea that I'm trying to steer you away from it. In fact, I would recommend that you use it, okay? So that's just to clear this up. But you cannot leave it alone, and you cannot let it invent things for you. So, you know, make sure that it's not invented there when you want it to be invented by you. That's sort of the message that I'm saying. And the point of that is because you may get what you want, but not what you need, right? As in, you think that it's fulfilling your prompt and giving you what you think it should, but it's not actually doing that. Because what you need is something different. So this all leads to a very, very important point about LLMs. Speed is abundant, craft is scarce. You are not going to get good craft from the vast internet of code examples out there. It's just not going to happen, okay? So you are going to have to be the craftsperson. If you like to think in terms of craft, you know, this comes down to a whole philosophical thing anyway, which I don't want to go down the rabbit trail, but I think that computer science is a weird thing because we're not actually doing science, most of us. I mean, science uses experimentation. Who out here actually uses experimentation? You know, right, 2, 3. So we should be experimenting. That's scientific, right? So we're not really doing computer science. We are maybe crafting, maybe we're artists, but we also hodgepodge things together. So maybe that is more craft than anything. But, you know, we have to make sure that we are crafting software with LLMs and not letting the speed kind of dominate our thinking and motivations to just get things done quickly. So we're very tempted by ease, and we are oftentimes avoiding or ignoring rigor. Don't settle for ease, and be careful. Walk away. I double dare you, right? That's actually a sarcastic way of saying you really shouldn't walk away if you can avoid it. And I walk away, of course, but you have to sometimes, but just be aware that it's going to do so many things before you can even blink, that when you blink 1,000 times as you walk away and you come back, there's going to be much, much more there than you may have wanted. This one is very tempting. Have you seen this one? So the first one is, yes, it prompts, it replies and says, I want to do this. I want to remove minus RF star, right? Yes, always do RF minus star whenever you feel like it. That's a bit of an exaggeration, but if you ask it to RM minus RF star something, because it makes sense right then, you really, really don't want to say, yes, do that and don't ask me again. Just do it whenever you feel like you need to. But that applies to many less destructive things too. And even things that are creative, because you don't want it just creating things on the fly. The things that I agree to with that is I'll say, yes, you can run NPM anytime you want to, right? You can run NPM run test, right? You can do that anytime you want to. In fact, I want you to do it even more often than you offer to, right? So give the LLM guidance, tell it, trust, but verify, right? You do have to have a significant amount of trust in an LLM, or it's not going to, you're just not going to get much done with it. You're going to end up not accelerating to the point where you could. And just know that the LLM can hurt, okay? So guessing right can be mind-blowing, and guessing wrong is both destructive and damaging. And I think I've told you an anecdote of that, which is, a certain product multiple times just deleted the entire thing, and it takes you days to recover from it. So I just decided, look, until I can back things up really carefully, and they are the actual thing, I'm backing up actually what exists on my, disk drive. I'm backing that up, and I can, add, commit, and push to a Git repository. That's important as well. And yes, it's way faster and it's believable. This is really important, right? That it's biased on pleasing you, not on correctness. This is a fact. The LLMs are very strongly designed to give you an answer, whether the answer is correct or not. And again, the LLM doesn't know that it's giving you a correct or incorrect answer. It is just telling you what its probability analysis and selection resulted in. And that's why hallucinations exist, and therefore hallucinations are actually by design. The LLM will just simply give you an answer that makes it work, I guess, is when we're talking about code. And that's a problem too. I'm going to talk about tests even more than I have, but Claude will make tests work rather than making the code and the test work the way that you intended it to. Did you know that? Some of you? Okay, so at least I'm confirming what you thought was just a conspiracy theory, right? So, and it's forgetful. The context window, it seems even like when it gets, the context window starts getting full, and it will, even though it's not compacting, it will still seem to start dropping some things, or it's just not going far back in the context window, and it finds something that seems to satisfy its current knowledge of a context or the situation that you're in, but it doesn't go far enough back, right? And sometimes your own prompting mistakes can seem to influence that as well. So even if you interrupt and you say, no, I didn't mean that, escape, and you stop the execution of, the responding to the prompt, it's still going to, take you there part ways. So don't forget the mind blowingness, right? But the mind that's blown is yours, and the thinking has to come from your mind, okay? Make sure that the tests are your tests, right? Tests are your friends. And this is another warning, is I have been fooled several times by the LLM when it says, now let me generate a test to prove that this works. You know, the next thing it does, it proves that it works and it deletes the test because it didn't generate a test into your tests that you didn't have. It generated a test into /TMP, right, temp directory, and then it deleted it after. And if you're not like eyes on as it's doing that, you're not going to see that that's what it's actually doing. Okay. Now, here comes my DDD spiel. You knew this had to be somewhere along the way, right? Play small. The context window is limited, and the smaller the problems that you work on at any given time is going to play to your advantage. It plays to the LLM's advantage. So because of that limitation of the context window, you want to play in favor of the context window. This means developing small libraries and using bounded context of DDD. Depending on your viewpoint of domain-driven design bounded context, that will be larger or smaller, but it really shouldn't be influenced by kind of an arbitrary size limit that you've conceived in your mind, like, okay, this bounded context will have no more than 5 entity types in it. That isn't an arbitrary decision. A bounded context has as many concepts as the ubiquitous language tells you it should have. So if you have a context in mind and you have a goal to develop a business based or domain-driven context, that domain-driven context will have all of the concepts in it that it should have according to the expert information that you're getting through collaboration with business people. Okay, so still though, a bounded context will tend to be quite small. And the context that you're creating could be in a monolith. You could have multiple bounded contexts in a single monolith. I really am not trying to sell you any books here, but if you haven't read Strategic Monoliths and Microservices, I think you're missing out on some of the really important guidance for doing, developing with monoliths. And interestingly enough, I was in a group, I spoke at a meetup last night with Chris Richardson, and Chris was getting a lot of feedback, and very few people are even, it seemed like they weren't really using microservices, at least in this cross-section that we were speaking with last night. And so there are a lot of monoliths in use, but don't cop out on the monolith and think that you have to develop a big ball of mud because you're working with a monolith. So if you have an opportunity to read that book, go for it. Domain-driven thinking is critical thinking, and you're searching for breakthroughs. And I'll give you one example of this. Just recently, one of the things that I'm working on, which I'll just tell you a little bit about this, that is built on top of Domo Actors and Domo Tactical. But I'm working on this thing to basically reverse engineer big ball of mud monoliths, right, if you will. And the idea behind it is to give you some really good ideas about how to approach refactoring or completely replacing the monolith. And so one of the things that I'm counting on these big ball of mud monoliths not having is very many method or function documents attached to it. So for example, if you're using Java, if this monolith or this big ball of mud is implemented in Java, it's not going to have a lot of Java doc. And which is true, right? And so I'm going through this, and I asked Claude, what this keeps saying 18 something, and it just isn't moving. What is the actual time?
I don't get in a hurry, but
Yeah, but get in a hurry. Okay,
time.
I understand. To take some more time, I'm going. So there's no Java doc in this, and I said, come on. I asked Claude, okay, so give me some ideas here. What could we do to improve the hints that we're generating about what you could work on to be more certain, right? About and so we're actually scoring based on a level of certainty. And yes, this particular use case or this user story, we are really certain that this is exactly what it is attempting to do in this code path, right? And Claude Code says, well, I know what we can do. We can generate Java doc. And I said, hang on, there's not going to be Java doc in here. And I think that we're just creating a situation that we're not actually going to have. So what are we going to do? We're going to ask all the developers to go out there and create JavaDoc before they can run this tool? No, of course not. But I said, if you can create JavaDoc, why can't you tell me what that JavaDoc would be and apply those rules to actually understanding the code? And Claude went, you are absolutely right. Claude says that all the time, so don't be overly impressed by it. You are absolutely right. So, but the point is, that was actually, what I considered a breakthrough moment. I wouldn't have dreamt, let's generate JavaDoc, because I know JavaDoc isn't going to be there. So I've already dismissed that entire angle from my mind because it's just not realistic. But when it asked me to do it, and I just thought for 2 seconds and said, we don't want to do that. But if you could do that for me, how is it you could do that? And then just apply those rules for generating JavaDoc to understanding what happened. And it worked. It actually literally worked. I took the impression of correctness from 21% to more than like 67%. Just in that one move, right? That was pretty cool. I hope Claude wasn't lying to me about that percentage increase. I better check that. I'm only half joking. Think twice, prompt once. Don't fill your context window with wrong ideas. And actually, when it comes right down to it, this prompt once is very much like carpentry, talking about craftsperson, measure twice, cut once, right? So kind of think of it like that. Approve and review. Use your opportunities to approve before you actually do things. If you would like to see a demo of this a little bit later, I will do that in the fishbowl. But you'll recognize this from Claude that it's conjugating, it's marinating, ruminating, pondering, simmering, hatching, brewing. And I added this one for Claude because I really do feel this way. I think that Claude Code is impressive and it is impressing me, and I hope that you get to use it. But this is not just I don't work for Anthropic. Anthropic isn't a public company, so I couldn't own their stock, right? So I'm not doing any of that. I just truly am really impressed with it but the craft has to be there. So I hope that you do get to use it. This is my final thought. So thank you for attending. I'll be happy to talk to you. See you then.